All right, so we looking at quarter four now?
Yes.
Ah, that's always a good thing. So quarter four consists of some projects that allow us to start expanding ourselves from the role of just a simple, uh, you know, components and assemblies to much more complex components and assemblies. And what happens at the end is we put it all together into some systems. So yesterday I showed you the basic analysis tool, and I think you're going to find that that tool works pretty decently to tell us what's happening. So quarter four, we go into structures and forces, and I touched on that a little bit yesterday, where we talked about moment of inertia, or the second moment of area, and we also talked about how we begin to evaluate design and what the various factors of safety are implied. So this project involves students designing a pedestrian bridge to go from point A to point B. Now, if you've ever visited Las Vegas and you've gone down to the Strip, you see these little pedestrian bridges to go from casino to casino. They don't want you to have to slow down and wait, because then you might realize how much money you're losing, so they keep you going. So you're going to find that pedestrian bridges come in all sizes and all flavors, and this allows students to take a look at bridges and bridge designs. They could go interview a civil engineer to touch base on what it is that they do. So they're going to go through and they're going to figure out how much weight the bridge will have to carry, and then they're going to basically design a bridge to carry pedestrians. Now, pedestrians are much more difficult to plan for than cars, for example. I was working with Chevron, I want to say back in 2010 or 2011, and we were doing a program we lovingly called The Science of Golf. And, it was done in conjunction with the PGA. And so, I wrote all these projects for kids to do so they understood the physics behind golf. And, so it was really a cool thing. And they made a video series out of it and that type of thing. But the next thing that they wanted to do was for the Golden Gate Bridge's anniversary, they wanted to do the science of the bridge. And so as we looked at that, they closed the Golden Gate Bridge to traffic, and they told people that they could walk across the bridge. And it was the scariest thing you've ever seen, because if you picture a wall of people walking across the bridge, everybody stepping, so it was lots of impact loads, and it was really a much greater load than the bridge was designed to carry. So I don't know if you know this, but a lot of bridges have sensors built into them. So we know exactly how much the bridge is deflecting and how much load is going on it. And, they can let us know when things aren't right. And so at any rate, we had to close the bridge off so people couldn't walk across it. So we could empty the bridge. It was like one of those great ideas whose time hadn't come. So that's the first project in quarter four. The second project is a hybrid toy connector. So how do you go from, say, a Lego to a Tinker toy or a Lincoln Log? And so it's lots of very careful measuring, and how do we make the transition from piece to piece? So they're designing something that has to fit two different things. And it's one thing to design something and then design something else to fit it, but to take an existing product and design something that works is much harder. So you'll see industry has these, laser scanners, so we can take a look at an existing part and recreate it, or take an existing part and create the design for it so we can design something to fit. So that's used a lot when we have really antique things that aren't functioning anymore. So there's a pretty nifty piece several years ago, this guy is an antique car collector, and he had to build a valve to allow the steam to pass from place to place. So early automobiles were either steam driven or electrically driven, so then the gasoline motor came in slightly after that, and just due to the way that gasoline folks work things, we all translated into gasoline, and now we're going back to electric. So who knows? There's a playground design project, and what this allows us to do is to split your class up into design teams, everybody working on the same large project. So maybe one group is working on a whole set of climbing bars, another group is working on a slide, and another group could work on merry-go-round, and then the groups have to talk to one another, lay the whole thing out, and make it age appropriate. They explore like handicapped access, the American with Disabilities Act type of thing. So there's really a ton of stuff that they get to do, which it takes them beyond the realm of simple design a product, but design a product for a specific place, meet the regulations, and make sure that what they're designing meets the customer's needs. So there's a lot of talking. So it basically gives them a lot of room for exploration and research. There's one on centrifugal pumps, and this is one of those things where in the chemical industries or the energy industries, understanding how pumps work is kind of critical to the whole thing. And so by designing and building one, they get a chance to really take a look at how these things work. Now, the picture there is a pump that I designed and printed out probably 5 or 6 years ago. And printers weren't quite as good as they are now. So, I managed to get some threads in there, and I threaded some fasteners in so I could connect things to it, and I turned the motor on. And it was like a lawn sprinkler, and like every little tiny break in the surface was oozing water. So in addition to going out the pipes, it was also going out the sides and the back, and it was a great learning experience. So a couple of the kids in the class decided that if they took fingernail polish, they could probably seal up the inside and the water wouldn't seep through the edges. So it was a great troubleshooting opportunity for them. This, I think, is my favorite project out of all of them. Having taught a couple of kids to ride bicycles and several grandchildren and the neighbor kids and stuff. Training wheels are great because they help keep the bike stabilized. But what usually happens is just when they're starting to really get the feel of how a bike works, they run down in a straight line and they pick up a little speed, and then the training wheel hits the ground on one side and they lean a little bit, and then they lean a little bit more, and it drives them in a big circle and off they go. So if you can design a set of training wheels to, kind of like sense what the bike is doing, and then, basically adjust themselves, or, adjust themselves up so it allows you to go so far. So it's not an all or nothing. It could be, like a range of things. So, I really got a big kick out of that. This project, which is the mechanical bank, is like a study in mechanisms, and there are a tremendous number of old-time mechanical banks. There's a whole association of people that collect these things, and basically they were designed to encourage young people to save. They would put pennies or maybe a nickel or a dime on the hand or in the mouth or whatever the mechanical bank was, and they'd hit the button and it would swallow the coin and away they'd go. So kind of a neat study in mechanisms. There is one here on basic glider design. So how do you take foam and design patterns for it and get this foam cut into a shape and put together so you can actually fly it? And it takes a lot more trial and error than you might think. So, and you can get foam relatively inexpensively. I used to use the white presentation foam boards. They made excellent pieces. We even got to the point where we were putting electric motors on them and 10-inch propellers. And, you know, if you built it right, you could fly the thing for 10 or 15 minutes. First learning how to fly, you end up crashing it a lot. But other than that, it was fine. So then there's another, or the last project is really what we call a child's toy. And this one is an example using cams, you know, so they turn a crank and the cams walk the marbles up a ladder and then it rolls down and goes back to the beginning again. So you turn your students loose to kind of think about what children might like, you know, let them introduce or interview young children and young parents and say, okay, what kinds of things are you looking for in a toy and what kinds of safety do we have to pay attention to? So that kind of, you know, covers quarter four. And hopefully by now you can see how the skill sets you learned in the very first few things you attempted really apply to all these other things. So it's a chance to specialize a little bit in terms of research and reporting and designing things for clients. You're going to use different sections of the software, and part of the research is going to be deciding what they need to learn how to do. Now, I've watched you know, several things as you work through this week, and you could tell somebody would get to some place and they had an idea for a project and they would dig in and they would not let go until they had it. And it really speaks highly of this method of learning, because if you refuse to accept no for an answer, you dig deeply and you find a lot of ways that don't work, but you also find a way that does. So that's really encouraging to me. That's what I look for in these things.